Next, let's talk about nested loops. So we saw nested if statements, that's having one if statement inside another if statement to create additional branches of our if statement. Nesting loops is a similar idea. The loop body can have any code, so that code might even be another loop. So here's a simple example. We have two loops. We have for x in range 1 to 4 and for y in range 1 to 4. And the body of both of those loops combined is just going to print the multiplication of x times y. The reason we're doing this is so we can follow along in our variable table so we can see how these loops interact. So the outer loop, as it's called, this first loop here, says create a variable x and give it the value 1. So when that runs, in our variable table we have x equals 1. Now this works just like a regular for loop. It takes one value from the variable and it says execute the body of that loop. So everything that's indented past this for loop. So that includes this inner loop, as well as the print statement. So this other inner loop follows the same rules of loops. It says create a variable called y and give it the first value in its range. So it's a separate version of that range function. That says create a variable called y and give it the value 1. And now we enter the body of that loop, which says print the value of x times y. In this case, 1 times 1, so we output the value 1. Now, here's where the tricky part about nested loops comes in. Now that we've reached the bottom of our code, where do we go back in our repetition? To answer this, consider what the outer loop is saying. It says, for each value of x, do all of this work. Now, inside that set of work is another loop that says, for each value of y, do all of this work. So for a single value of x, it's going to go through all of the possible values of y. And then it'll grab the next value of x and do all of the possible values of y again. So once we reach the bottom of our code the first time, we come back up. We're still inside this inner loop, so we repeat the next value of y. Notice x has not changed, and y now has the value 2. We print out x times y, we get the value 2. We're still inside this inner loop, so we go back up again. We get the next value, which is 3, and we print 1 times 3. Now this inner loop is done, right? If we go back up, there's no more values, so this loop is complete, and we go back up to the top of our original loop. So x now gets its second value. X gets the next value from the range and it says enter the body of that loop, which says, look at this, there's a for loop in here. And it's a brand new instance of the for loop. So it says for y in range 1 to 4. So y gets the first value from that range again, which is 1. And then we print out x times y. But now we get the next value for the y range and the next value. And now we finish the inner loop a second time. We go back up, we get the third value for x, and then we start over inside the body of that loop. So it says make a new loop here, give y the first value from its range, print it out, get the next value, print it out, get the next value, print it out. So for each iteration of the outer loop, we do all of the iterations for the inner loop. So to put this knowledge to use, consider the following programming task. We want to write a program that asks the user for a number, call it n, and we'll display a pyramid of numbers like the following. Now we'll assume the user only enters values from 1 to 9 because once you have double digits, this pyramid structure gets difficult to manage. So we'll assume only single digit numbers. And the idea behind the drawing is that on the first row, we'll have 1, 1, and then we'll have 2 2s, and then 3 3s, and then 4 4s. If it's up to 9, then we'll have 9 9s in the last row. So let's decompose this problem to see if we can't figure out how to solve it using nested loops. So there's 2 stages of repetition. We have multiple lines, and on each one of those lines we have multiple characters. So let's say the user enters a value 5. How many lines are we expecting? We're expecting 5 lines in our output. So at one point we need a loop that repeats n times. We'll call this our outer loop. Now for each one of those lines, we have to figure out how many symbols are we going to put on that line. So on the first line, we want to have 1 symbol. On the second line, we want 2 symbols. On the third line, we want 3 symbols. In general, we could say on line I, we need to have I symbols. So having an inner loop that prints one character I times. So let's go to our IDE and try to solve this. Let's make a new file. We'll call this triangle.py. And this is a challenge to print a pyramid of numbers based on the user input n. So before we try jumping to the final solution, let's start on a smaller sub-problem here. Let's just try drawing the very last line. How can we print, let's say the user enters 5, how can we print 5 5s? So a real simple attempt at this might be something like for j in range 0 to 5. print 5. We'll say Python triangle and try it out. We got 5 5s, but they showed up on different lines. So we're going to have to come up with a different attempt at this solution. One way to make all of these print statements show up on a single line is to only include a single print statement. That is to say, we'll use our loop to build up a string, and then we'll only print out the result. So I could say out is equal to an empty string. Instead of printing, we'll say out plus equals the string of 5. And then when we're done, we could say print out. Save and run our code, and now we have 5 5s on a single line. Great. So we've gotten a little bit closer to our solution. We got the first step done. We can print out, let's say, the last line here. Next, we need to do that 5 times because we want 5 lines in our output. So a way of solving this is just to repeat this whole thing 5 times. So I would say, take all of our old code here and put it in a loop. So I'll say, for I in range 0 to 5, do all of that. So here we have an inner loop, which is just printing one row of 5s, and we have an outer loop, which is constructing the number of lines that we want. Save and run our code. And now we have the number 5 printed out 5 times on 5 separate lines. Might not seem like it, but we are getting closer. Now, instead of printing all 5s, the first line is supposed to be 1s, the second line is supposed to be 2s, the next line 3s, 4s, etc. So how can we replace the thing we're printing with the number of the row that we're on? Well, here's the thing we're printing. We're just taking the value 5 and we're attaching it to this output, and then we're printing it out later. So this is where the 5s are being constructed for our output. So rather than saying 5, we could use the variable which is containing the current row number. Now note, the inner loop here is working more on the columns, so the outer variable here is the one controlling our row number. So we'd say I. Let's try this out, so save our work and run it. Pretty close. So we got 0s, 1, 2, 3s, and 4s. So this is what's known as an off by 1 error. It's pretty common when dealing with for loops. You have to check your edge conditions to make sure you're using them correctly. In this case, we wanted our loop to start at 1 and end at 5. So there's a few ways we could solve this. We could change the range that we're dealing with, so we could start at 1 and end at 6. We could also just take the current value and add 1 to it, because we're off by 1 every time. I prefer the former, so let's do that. So we'll start with 1s, and we'll go all the way to 6 in this case. All right, trying again. Now we got all of the numbers, 1, 2, 3, 4, and 5. Next, instead of having 5 digits per line, we would like to have I digits on the ith line. So 1 digit on the first line, 2 digits on the second line, etc., all the way up to the last line. Now recall the loop that's controlling the number of digits per line was the first one we wrote, this inner loop here. So this is saying always go from 0 to 5 and add that many i's. So what we need to do is change this so that instead of being from 0 to 5, it's controlling the exact number of steps that we want per line. Now we want the number of digits to change each line, so this range should be dependent on this variable that controls the current line number. So let's try going from 0 to I. Run our code, and we get 1 1, 2 2s, 3 3s, 4 4s, and 5 5s. Excellent. So we're almost there. We got the triangle that we wanted, but now it's always going to be this same triangle from 1 to 5. So the next thing we need is to modify this code to allow for some user input. So let's start by getting some user input. We'll say n equals int input, enter a number in the range 1 to 9. Now again, we'll assume the user plays nice and gives us an actual digit in the range 1 to 9, so when we convert it to an integer, it won't crash. Now that we have this variable n, we want to use it in our code to control the number of repetitions. Recalling how this code works, the outer loop is controlling the number of lines in our output, and it's currently going from 1 to 6, which will always be exactly 5 steps. The user enters a 9, we want them to go 9 steps. So we're going to change the upper bound here. Rather than being 5 plus 1, we will say n plus 1. That way it starts at 1, goes up to, and including the value the user entered, constructing one row of digits for each such value. Save our code, run it again, And now it asks us to enter a number. So let's enter the same number we had before, enter a 5. Nothing's broken, so that's good. Run it again, and let's enter, let's say, a 9. And then we have a triangle of 9. Run it again with a triangle of 1, and it's just the single digit 1. And there you have it. So this simple example demonstrates the utility of having nested loops. So remember, we have an outer loop which controls how many times we're running through all of the code inside it, and we have an inner loop that's also doing repetitions. I should point out there's a number of alternative solutions to this problem, one that uses string multiplication, for example, but even string multiplication implicitly requires its own repetition. So we're still nesting loops, just in a way that we don't necessarily see it. So that's it for this example. That's also it for this chapter, where we covered all things repetition. So we saw while loops and for loops and break and continue statements and all the ways that we can combine them. And that's also it for this video. I will see you in the next one.